We're just gonna continue the. I'm kind of into it, man. I kind of like the Vulkan tutorial, so we're gonna continue that. And then I think I might do a bit of it. It does cook my brain quite a lot, so I think we'll do a palette cleanser of maybe some Go programming. Gonna work on some web app stuff. Okay. Well, first off, let me get it working on Windows, but we're going to switch over to Linux. It's far easier to work on Linux. Learn Vulkan. Oh, I might have to rebuild it. We'll see if it works. Yeah, okay. Okay, while that builds, let's go over here. Okay. Alright, so it's running. Yeah, we got this working last night. Okay, just gotta confirm it works on the Windows, and we'll come back to Linux. And actually, I feel like some coffee. Let me go grab a little bit of coffee. I'll be right back. I bought this coffee. It's a winter blend. It's a Trader Joe's winter blend. And I'm drinking it. I'm like, man, this just smells like something. It smells like something. I'm going crazy. I'm like, what does this smell like? There's this this dish I had in Thailand. I mean, it's probably okay for like most people, but one of my favorite foods ever is called Kai Hello. This. This coffee uses the same spice as Kai Hello. So I've been drinking it for a couple days, going crazy. Like, I know I've smelled this, then I'm like, it's Kai Hello. So after I realize it, I can't drink the coffee anymore. Because it smells like I'm drinking this stew. So anyways, I'm going to get some different coffee. I poured that all out. With a coffee that does not taste like beef stew. Alright, let's see if this works on Windows. And then there's some concepts that I have to nail down. I have to understand why you transition every time you draw. It seems horribly inefficient, so I'll have to see what it is. I haven't had any coffee yet. What? How's that possible? Actually, I've cut back on my coffee significantly. I just do one in the morning, and then I drink tea all day. Alright, cool. Alright. Nice. It's working. Do I have... Hold up. Yeah, okay, that's off. You have like 8 in a day? I was like that too, yeah. Yeah, I'm gonna recommend, I had to get off it. It was wrecking my stomach and like, you just can't. But see, I was drinking 8 or 9 espressos a day, which is very different. So now I do like a little bit of iced coffee or just like one coffee in the morning, and then I try to do tea all day. And I'm now getting to where, like, because I want to start having a regular sleep schedule. And I know, man, I used to be hardcore, could just drink coffee, no problem. But I guess as I get older, I'm becoming more like a baby. Although today I haven't had one yet. Nice. I believe today is PG tips. I do PG tips and English breakfast, and then I'll do a rooibos at night. Okay, so that's working. Let's go Linux time. Let's bring you to about right there. This to about here. You know, I need to find a replacement for what's it? God damn it. Zoom it on Linux. If I could find a Zoom it alternative on Linux. Okay, cool. We got something. Something I can use to point at things. Makes it easier for the presentation. All right, now we're going to do the next part of the Vulkan tutorial. Okay. Push constants and new shaders. Okay, nice. Make sure that still runs. Awesome. Okay, so we got that, and then VK engine probably. All right, let me see. Gradient color comp. Okay, compute shader. We have a way to run compute shaders to display and a way to add debug UI. Let's use that to send data to the shader. All right, we will use push constants to send data to the shader. Push constants are unique to Vulkan. Allows some small amount of data to be sent to the GPU. Keeping this data small is important, as most drivers will have a fast path if the data is below some bytes. Consult GPU vendor documentation. They should have standardized that. Yeah, that's kind of lame. Its main use case is to send some per object indexes or a couple matrices that change for every object. If you have data that's bigger than a handful of floats or ints, you should be using other systems from the next chapter. Okay. Push constants are configured when you create a pipeline layout. To keep things simple and not to have to change too much code, we're going to default our push constants for compute effects to 4 vec4 vectors. That's 16 floats. All right. And then we have some compute shaders. It'll blend between 2 colors by XY coordinate. Okay, cool. All right, so this is the new shader, gradient color comp. Okay, let me get this organized a bit. And let's do that. Yeah. I don't know if I'm going to bother typing this out, I think. What are they called? Gradient color comp. But I'm not here to learn shaders. I'm here to learn Vulkan. All right. So let's say layout, push constant. Constants. Data 1, 2, 3, 4 and a vec4, push constants, and you access it with that. Interesting. Interesting. Okay. Okay, now we need to add that to the build. Not there. Okay. So it's the same as the gradient shader we had from last, but we add the push constants, which is 4 vec4s. We now need to change the pipeline layout creation tool to configure the push constants range. Let's first create a structure that mirrors those push constants in VK engine. Got it. VK engine. Okay. That gives us that. To set the push constant ranges, we need to change the code that creates the pipeline layout at the start of init pipelines. Is it in here, or is it init background pipelines? Ooh, that might be a mistake in the writing. Size of push constants. All right, I'm going to assume it's here. Okay, so again, yeah, the constant pattern is just, yeah. Yeah, so it's always you create some structs and then call a function to configure that thing with the structs. I know there's a way to do that easier, to make that way easier to work with. Man, I just know it. Anyways, I'm just gonna grab these. Since they're just config info, it's not super useful. Right, yeah, so you just type pipeline layout, create info. It's pretty much, yeah, pretty much the same there. And then this is shader stage compute bit. Same deal. And then we do compute layout. A push constant ranges equals push constant. Yeah, so that sets the push constant size, push constant range, right? And the kind. So offset 0 and then its size of the struct. Okay. So you could possibly restructure that a few different ways. And what is it we need for the final part? Okay. Okay. And we need to add the push constant range, the pipeline layout info. Okay, that's fine. And after that, just add the shader to be compiled to be the new one. Okay. So then we have to do load shader module to this one. Gradient color.spv. That's all we need to add push constants to the shaders. Let's now use them for the render loop. I gotta be more, consistent about where that goes, man. I got no idea where this goes. Are we doing command? Nope, in the render loop. Let's now use them in the render loop. VK bind pipeline. So I'm gonna probably assume I mean, it could be in draw, could be in draw background. I'm assuming it has to be before all of this. Yeah, it's got to be in draw background. Bind descriptors. Yes, it most likely replaces this. All right, I'm going to take a leap of faith and assume that it's replace draw background. Got to be more explicit of exactly where the code goes. But it looks like, yeah, this is the part that's using the shader to do the drawing. That's why I don't try to type those out, man. They're pretty bad. Alright, and then bind the descriptor set. Yeah, we'll just copy that. There's way easier to do that. Okay, so we'll bind point compute the gradient pipeline layout. 01 image descriptors. Okay. We'd have to look up those functions each, so we'll have to see what those actually do. PC. Oh, okay. I was about to say, where's PC? Compute push constants PC. Data 1 equals GLM vec4 1 0 0 1. You see data 2 equals GLM vec4 0 0 1 1. Okay. VK command push constants. Yeah, this is totally, it's just a, yeah, it's just a transaction. So you're just adding on to the command and then you commit it. So, you know, like in SQL, you build up a transaction and you commit it. But with just a shitload more code. That's like a fucking ton of code. Okay, and then VK dispatch And then we do this. That's just width and height, right? Yeah. Okay. Let's make sure that compiles. Let's run it real quick. Confirm we don't get any kabooms. Okay, that's cool. I believe that's probably right. I don't know. Should it be? That seems to me like it's like a memory corruption. Interesting. Okay. Let's double check this code real quick. Yep, gradient pipeline there. Draw image descriptors. 1001, 011. Compute bit size of push constants. Push constant. All right. Oh, wait, but he's not setting the other two elements. Yeah, because there's 4 elements, and if you push the whole thing, then 2 of them don't get set. Okay, it must be that that's getting set later, but let's try something. Yeah, because these are going to be uninitialized RAM. I'm probably right. Let's just see what we get when we actually set those. So probably, yeah, weird. I don't know why I would do that. It's kind of strange. All right, well, let's continue. I imagine once we get the IM GUI stuff up, it'll probably work. Yeah, so this is an alpha. So this would be RGB. So that's red. And this is RGB. Yes, RGB. Okay. All right, let's wait until we get to the end, but I think there's possibly an error. All right. Maxerator, let me see. I'm curious if you know how difficult it is to make a programming language binding to OpenGL Vulkan. Is it true? Let's see, C++. Well, so Vulkan and OpenGL are written in C. And pretty much every language can bind to C. It's sort of like the de facto standard ABI. So everyone that wants to use like compiled stuff, every language can do C. The one that really gets you, that is like almost impossible, is C++. Because C++, every compile, there's no, like kind of no standard for how things get mangled, and the ABI isn't standard. So like to do C++, you have to do some crazy things. Actually, there's a language. Jank is C++. So the Jank programming language is like Clojure, but written in I think maybe it was originally written in C. And this article is really interesting because basically what they had to do was embed all of Clang just so they could call some C++ functions. Yeah. So yeah, just to be able to do some stuff, they had to basically, yeah, it was pretty hardcore. But just look for that. Jank is C++. It'll give you a good rundown of what you need to do. Yeah. And so then an interesting thing is, and I've been meaning to kind of play with Jank at some point. Now then there's a language called Nim, right? Nim has a really interesting way that it does things. So if you look at this language is totally different, right? It's not C++. But Nim is this really complete, fully featured language that has a lot more features, like usability features, than C++, right? But it just compiles down to either C++ or C or JavaScript. So if you want to access C++ stuff, trivial, so easy, like very, very easy to access C, C++, create front-end stuff in JavaScript. And it's like the same code will compile down to all those targets. So Nim is kind of like the ultimate, like if you have to glue together a bunch of C++ libraries, Nim is probably the bomb. It gives you this kind of nice Python-ish, kind of modernized Python syntax. Has kind of a, I would say it's much more inherited from Object Pascal, right? Like Delphi than it is from, say, Python. And then also the attitude of the Nim compiler people is that you have full control over the compiler. So you can like create crazy macros and stuff like that, and they, you know, pretty much work. And you can totally modify how the compiler operates. And in fact, that's how most of the compiler is written. It's kind of written in itself, and then they compile based on their own changes. So really interesting, like same attitude as C++, where like they don't try to do anything to the base language as much. Instead, they will try to write macros and whatnot that make it so that they extend the language that way, right? But the difference is NIM's macros are way, way better than C++ templates. Like they're literally first class, and they have a whole bunch of features make it so you don't even know, you notice that you're using them. So there's kind of two approaches. One, Jank, they went in and kind of said, okay, well, I guess we're just going to become Clang and just embedded all of Clang. At least that's what I think they did. And then Nim is like, yeah, if we want to work with C++ and C and all these languages, let's just like compile to that. And we'll just generate C++ and build using that. Which is also like a really good way to do it, right? And then there's like Go. Go has probably the worst way to do it, which is does the C Go stuff. It's like super slow. I think they're like shuttling data back and forth inefficiently. Like it's not as good, not nearly as good. What the hell is Clang? Clang is just another C++ compiler. I probably have it. Yeah. It's kind of the only legit competitor to GCC. And it uses LLVM, which a whole bunch of other languages use. So the back end is LLVM, and then Clang does C and C++. Okay, so now, all right, we need to add editable parameters to our thing. Okay, I'm trying to make a website with AI. It's weird, but for websites, every time I try to do something, they want money. Like, dude, all you gotta do is pay $50. Wait, the AI tool, like the second they notice you're trying to build a website, they're like, hey, give us $50. For $50, you could just go like create a website on Wix or something like that. $50 will get you really far on any of those website builders. Yeah, that's dumb. If all you want to do is make a website, then any of those other companies would probably do better. And DreamHost? Yeah. I mean, honestly, making it yourself is going to be way more educational and cheaper. $5 a month. Then you use AI and it's $22 a month. The AI looks good. I mean, be careful. People can generally tell if you did AI on a website. Like if you're doing it for job applications, they totally know. All right, folks, we'll do this next part. I need to take a break super quick. I'll be right back. Actually, we got an ad that starts in 4 minutes. So let me just run this ad, and I will be right back after the ad. So the ads are 3 minutes. Go ahead and go take a break too, or mute it, and I'll see you then. Let's see. Oxinitive. Use the actual docs. Yeah, sometimes though the actual docs suck. I mean, let's be honest, man. Yeah, I would love to do a course on how to write better docs. I think that would probably be the biggest improvement. But I also think for some weird reason, programmers think their docs are perfect, which is just weird. Like when I was going through the OpenGL stuff, is like completely out of order. Like you did this thing and then, oh, but I forgot you have to do that thing first. It was like just really weird. I'm like, how can you sit there and write docs and then not realize you did it in the wrong order? And I see that all the time, like constantly. I'm not sure what it is with programmers, man. They just can't write 1, 2, 3, 4. They go 1, 5, 4, 3, 2, 1, and then think that's normal. It's so strange. And yeah. So yeah, sometimes the AI, yeah, it helps. I sent some messages on chat about our C-strings conversation from yesterday. Oh, did I miss that? I have to switch over to Windows to scroll back. I investigated issues with C-strings, better strings. It's all about UB and complexity. It's not UB. No, that's a smoke and mirrors. It's not UB. Find the length of the string is ON instead of actually giving an answer O1. And funny when there are no 0. Yeah, you always have to include the 0 because of C, but you never use the 0 to figure out if you've reached the end. That's the trick. And also, to make it ultra safe, you have padded a few extra zeros at the end. And I want to use old-fashioned strings. I don't know why. That's incredibly stupid. Because if you are writing the language or the string library, you can make it do whatever you want. Make hash table that it does comparison by memcomp. Yeah, you can still do that with like a struct, man. With Back0, I can work on pre-allocated char array. You can still do that. If you know the size, none of the stuff you're working on, you know the size. Also, it's not undefined behavior that is the problem. That's what C people put forward, and it's just smoke and mirrors, right? All right, so here. So I'll say something like, we're going to talk about the Mott and Bailey fallacy. Mott and Bailey fallacy. All right, so the Mott and Bailey fallacy is this. I put something preposterous forward. I state something like, the universe is made of cheese. Now that's obviously not true. So people go, what do you mean? It's not made of cheese? You're full of shit. So then I retreat to the safe part of my statement, which is, oh, well, grilled cheese sandwiches are made of cheese, right? And by defending just that one part, it seems like I've defended the whole place, right? The whole Mott. But really, I only defended the Bailey. So by defending grilled cheese sandwiches have cheese, I've defended the idea that the whole world is made of cheese, right? Now that's ridiculous, but this is really what happens. People will put forward something really ridiculous. When you challenge the ridiculous stance that they put forward, they run back. I mean, you'll hear people say, you're moving the goalposts, you're moving goalposts. What they're really doing is Mott and Bailey. They go back to the safe thing to defend in the argument. And then when they defend that, people are convinced they've defended the whole statement, but they didn't. They only defended that one tiny part, right? Okay, so let's say I do char pointer, all right, so I got a C string, right? I'm gonna do a for loop. For int I equals 0, I is less than 1, 2, 3. No, actually, we're just going to do this. While zi doesn't equal, now this is the Mott and Bailey. That is defined behavior. Whoop, wrong character. This is a test that is defined. It is not undefined behavior to compare something to 0. That's the defined, totally defined behavior. Okay. And then I go I++. Okay. Now I do something with that in here. Now, this is a situation that everyone who uses C strings imagines. I have a pre-allocated, totally defined, when the program runs, setup. I've got the string, the compiler has guaranteed that it's ended. That's what they imagine, okay? So now, and for some reason my audio is really dying today. Okay, so now, let's do this. Let's take this, and we're going to make a function called print chars, and it takes a char string. Okay, given this information, it's impossible in C to know that this string is correct because of the defined behavior. This is not undefined. Checking if two things are equal is completely defined. In order to confirm that this Z string is correct, right, what do I have to do? I have to loop through the arrays. Let's say I want to do a check string function. That's an assert for checking a string. Well, how would I check that string? To check the string, I have to loop through the string looking for that ending. But doing that, looping through a string and comparing the characters to an ending causes the crash, right? There's no way to confirm that this string is correct just from the string. That's the failing. It has nothing to do with undefined behavior, right? Every single thing in here is defined. This is defined. Iterating through a list is defined. All of this is defined. Every part of it. The bug, the fatal flaw of C, is that because they end, the only way to tell if a string is correct is to trigger undefined behavior running through the string. It's flawed from the beginning. There's no way for me to go, oh, is this actually a valid string without causing a crash? And there's nothing you can do. You can't fix this. You can't fix it. And everything in here is completely defined. So you bring this up, and the Bailey people, they run to their Bailey. They go, no, that's undefined behavior. So they'll make you a little function, and they go, random pointer thing, right? And they'll give you something like integer pointers instead, right? Because they don't want to trigger the whole completely defined behavior, and they'll do find. And then they'll cook up some sort of like for I and I equals 0, I is, and then, you know, find I doesn't equal 100 I++, right? So it looks the same, right? They say, see, look, it's the same. You're iterating through it, right? Okay, but the thing that they're not doing, the thing that they've done is, I'm talking about C's string terminator. That's the topic. That's the indefensible position. The null terminator usage is what causes this indefensible, we cannot correctly tell if this string is valid thing. And what they do is they run to the Bailey, the safe thing to defend, that, well, you can't protect programmers from this because it's the compiler or the CPU undefined behavior. We're not talking about undefined behavior here. This is going to be a series of numbers that I construct in the code. This could be some input from a file or a user. This is an input controlled malformed piece of RAM, and you have no idea that it's malformed because of the base feature and how strings work. You can't make this correct. I can make this correct because I have created this, and there's no like input 100 numbers thing. I write that. So I can define it and I can add the size to it. So the Bailey is, oh, this is undefined behavior. No, it's not. I'm not talking about the pointer part. I'm talking about this part. The indefensible part is you have bad strings that you can't validate. So that's this. They're sitting out here. I go, yeah, you can't validate C strings. They're broken. They go, yeah, you can. It's undefined behavior. And they run into this thing to defend. So with this defense, with this pointer swizzling integers, have they defended the use of event nulls? No. They've just basically said CPUs crash when you use bad pointers. I go, you're right. CPUs do crash when you use bad pointers. And because C strings are made in a bad way so that you can't validate them and you have no idea how big they are, you are causing that for people. That's the mod. Nobody in the C community has ever defended that. They've always run to the Bailey, to the defensible part of pointers. But no, we're not talking about the pointers. We're talking about this and the fact that you have to trigger undefined behavior to confirm if a string is correct. And that's a bad design. And incidentally, it's the only language with that design. Every other language, they pre-size their strings because that's what you do. So that's the reason. In struct, you can have only one char zn, not const char, because my hash table does. Well, then change your hash table, man. Yeah, it's almost entirely like something you have to do to make it safe. Think about it. How else are you going to confirm? How would you write check string so that it never overruns the size of the buffer? You're never going to make it correct. You have to add a size and a capacity component. The capacity is mostly to ensure that the backing buffer has a size and then the contents have a size. And then you add you add this part to the string. You add this to the end of the string just because other functions need it. And that's it. Char and, no, you have no idea, man. Here, look. Where's the size? How do you get the size of this? It's just a C string. You have no other information. How do you get the size of it? You do a loop looking for this, right? So if you're given a malformed string, you're given a bad string, right? There's no way for you to tell it's bad because you just blast through the end of it. See? And that's the flaw. And I don't know why programmers are absolutely fascinated by this because like they love this design and it's terrible. You think about it. If I give you, and we could do a challenge. You write yourself a string library, but give me control over the input. And that's effectively what you're doing. The other big reason why C strings are flawed is they almost always come from external sources, right? Strings come from the external world. They don't always come from your, predefined configs and constants, right? So by having strings with null terminated like zeros at the end, you're giving the external world the ability to hack your program because I can find a way to pass you through network calls, data manipulation, handing you junk. I can find ways to give you bad strings. And since there's no way to confirm the string is bad or not, then you're screwed. You can't make it safe. Right? Because think about it. How would you write check string? Let's call it, right? What are you going to do? For int I equals 0, test I. You're looking for the ending, right? You want to make sure that it's properly sized. How are you going to confirm it? You have to find the end, right? You don't know the size of that back buffer. You don't know how much you're not supposed to go, right? So you're just searching for it. There's no way to write this without an additional, at least a size component. You have no way to check this. Let's say I'm going to write it this way. So what are you going to do? You're going to do strlen_z. Okay. If this string is malformed, strlen is going to blast through the RAM too. There's just no way to make it correct. How are you going to make it not blast through the RAM? Right? So that's why you never do C style strings, ever. They're always bad. But what happens when you challenge C people on it, they'll cook up some crazy ass, pointer swizzling thing. See, it's undefined behavior, bro. It's not. Nobody's talking about the pointers. We're talking about the null termination and the fact that you cannot confirm a string is correct without triggering the undefined behavior. So C strings are forcing you to have UB. And they shouldn't. Mott and Bailey. They put forward the statement, there's no problem with C's strings. I say, yeah, it is. You can't confirm a string is correct. They run back to the Bailey. They go, oh, well, it's undefined behavior. We don't have to make it correct. So then the counter to that is, yes, you have created a string system that forces undefined behavior on people. And in addition to that, strings come from external sources. So you've basically declared C completely ownable externally. And then usually the answer to that is, well, you just got to be man enough, bro. Well, okay, show me a code base that doesn't have this problem, because like everybody apparently is not man enough. All right, so that's it. That's my pitch, man. Don't do it. Array size, you have to have array size. Where do you get the array size? Where do you get the array size? With this function here, just this. Oh, let's use my fancy pointer. With just this, just that information, how are you getting the array size? Understand me right? I'm not defending. Oh, no. I'm trying to convince you the way. Now, I will give you a couple of ideas. What you can do, right? If you have control of the memory allocator, all memory allocators do this. So let's say I request like 20 bytes. Okay. What memory allocators do is they're calling some OS system, right? Like str break, or I forget what it's called, for getting RAM. What they do is they allocate a structure. There'll be like some kind of struct here. And this has the information of like whatever they need for the OS, how big it is, right? They construct this, and then they give you this as the pointer. And then there's this secret chunk of RAM that's kind of hanging out. So then when you do free, what free does is it backs up by that fixed amount, and then reads how much to deallocate and calls to deallocate, and then does other fancy stuff, right? So you could do the same thing. You can have your string library where you say, make me a string that's 20 bytes long. And then every time you go to operate on that string, you then just back up. You have your struct that says it's this long, it's this big, blah, blah, blah. And then you, if want to get the length, you back up by this fixed struct size. The struct is a fixed size, right? Back up by that much, then process it, but you only hand this string around. And I believe Anti-Res, he made a library that did that, which is pretty common. So if you don't even want to do that, at a minimum, what you could do, if you're writing your own allocator, you could have your allocator give you access to this. You could say, take this pointer, hey, allocator, how much is really in this? Okay. How much data is really in the buffer behind this pointer? And then it will say 20 bytes. So let's say it's malformed. You're never going to overrun the RAM, at least, because you'll know exactly how big the RAM is. So you can blast through it and you'll be like, okay, yeah, no, this is bad RAM, right? This string is malformed. So then you could write a checking function, but then think about it. It's ON to check it every time. So what you would really do is you would say, keeping it strict, you would say all C strings are allocated so that the zero byte is very much at the end every time. So you go, allocator, how big is it? It goes, it's 20. You jump to the end. If you don't see a 0 there, you go malformed string and then abort. And that would keep working with all of the string stuff, but you'd have to guarantee that all your C string calls use a malloc string, which, isn't too unreasonable. And then the only other thing you'd probably have if you did this, you want to confirm a lot with your own allocator. Put some kind of magic number here so that at a minimum, you back up your struct. The first array is, no, my sound is going crazy. Hold on. Your first element in the struct is a magic number constant. And then you back up. If you don't see that magic number constant, then you know this wasn't created with your malloc or it got corrupted somehow. And then you abort. Define array size of X. No, but you don't. Size of X is a pointer, my friend. It's a pointer. How do you get the size of this? How do you find this? It's going to be 4, right? It's not const though. Okay, again, Mott and Bailey, we aren't talking about a const sized array chart. That's the flaw. Everyone who does C, they're thinking of constant sized pre-allocated non-dynamic strings. But if you write anything reasonable, opening files, getting input from the user, network protocols, it's not like that. It's never a constantly sized thing, ever. You're dynamically allocating the RAM that you need to do things. You're creating the C functions, right? You understand the issues, but you're still going to do it. Okay. All right. I don't get it, man. I don't get why programmers just love this shit. It's so weird. Okay, do it. And then I'd be kind of curious. Yeah, all right, go for it. And then get into fuzzing. I would try to fuzz it. Passing it crap strings to see how it works. Okay, let me see. We need the next part. Yeah, interesting. Okay. Now let's add an array. Racing. Thanks for the 9-month subscribe, by the way. What UB do C strings force? Well, because you can't check if a string is valid without triggering a pointer going past the end of an array, undefined behavior. That means every C string is vulnerable by default. Also, not sure why my sound is freaking out today. So given a plain old C string, it's impossible to confirm it's correct without triggering the undefined behavior. That means the issue is not the undefined behavior, it's the way the strings are formatted. It's kind of like someone made a car and the steering wheel is defective, right? And the people who made the car, they'll go, yeah, if you drive off the road, it's not defined. We're not guilty. You drove off the road. But then they make a steering wheel that's busted. So people are driving off the road. They go, look, it's not our fault. People keep driving off the road. And you go, no, the steering wheels are busted. Go, no. Steering wheel's not busted. I'm telling you, people keep driving off the road. That's not our fault. That's undefined. That's basically C strings. Every time you try to point out the steering wheel's busted, the people who love C go, no. It's not the steering wheel's busted. It's because you keep driving off the road. You can confirm it's correct. It will work if it's correct. It will BUB if it's incorrect. Yeah, exactly. There you go. and then the compiler goes, ooh, undefined behavior. I can optimize this. I think that's the other crazy thing about C and C++, folks. Compilers just go like, oh, well, technically this can't happen. I don't need to tell the guy. I don't need to tell the programmer, yo, you have undefined behavior. Where are we adding this? Okay, we need to add this to, wait. Now let's add an array of them to the Vulkan engine class. Vulkan engine class, where do we add this? And why doesn't it have an underscore in front? Never thought about that. I don't know why. Like, and then C programmers are very determined to always keep it around. And it's, I mean, it's like the top reason that C is hackable. They keep looking at the pointers and completely missing, you know, the fact that they just have a whole bunch of data they don't know the size of. And they defend it to the end too. They make it seem like, you know, how dare you make fun of Dennis Ritchie? Oh my God. How dare you criticize Dennis Ritchie? And like, you know, really smart people make mistakes all the time. The people who are the smartest, though, admit that and fix it. Right? If you're over there defending something busted, then you're not actually smart. There are no gods. Okay. I wonder if somebody else wrote this code. It's kind of weird. Okay, and then this goes. We need the sky shader. Init pipelines. Holy crap. Okay, all right. Okay, we do that. I need to get this shader. And then we'll compile it. Make shaders. Okay, cool. All right. Oh my God, man. Wait, this isn't. Oh, okay. All right. So the tutorial is kind of falling apart at this point. It feels like it was kind of really rushed. In multiple instances, he said, "Oh, just change this," and it's not the right function. He doesn't explicitly say where things go. I feel like he got to a point and maybe got worn out or something, because like it seems like very sloppy at this point. Like, I got no idea where this is supposed to go, so I have to reverse engineer it. He's also saying we changed code on init pipelines, but that's not where you're creating the shaders. Yeah, because it's in init background pipelines. So just kind of sloppy, and I'm kind of curious, like, why would you not confirm this? Okay, so it's in here, and then we sort of have to... So I'm thinking it completely replaces this function. Yeah, create compute pipelines. Sky shader. Background effects. Push gradient, push sky. And then gradient pipeline layout. Yeah, so it looks like it completely replaces the init background pipeline part, not init pipelines. Push gradient, push compute, draw image. All right, so let's just try it. Yeah, it looks like it just replaces all of this. So let me just grab it, and then we'll see if that's correct. And then I'll write it mostly by hand to kind of learn it. Well, we'll just toss it in there and see what we get. Hey, Plutonia, how's it going? So far, so good. Compute push constants. Oh, it has to go after that. Okay. Yeah, we have to confirm. Am I converting my game to Vulkan? Oh, no. I have thought that, so at the very beginning of this tutorial, it got to a point where you can draw into a buffer, and that's actually all I need for the game. So I was like toying with it. I'm like, I could get rid of SFML. Okay, cool. All right. Now I'm just learning it for my own education. And in fact, I most likely won't use it. I would go and find something that's just a bit easier. A bit easier, so. But, you know, it's kind of like learning how this works. All right, so in theory... Okay, cool. Segfault. Okay, and then all right, I'm going to get this to work using this code, but I suspect this may be the end of the tutorial for me, I think. It's just way too rough at this point to follow reliably. It started strong, but now I feel like what's happening is the code is just not organized well enough. So you get to a point where the code doesn't support the narrative well, and it gets confusing. Like this code is really confusing. It's not organized well. Like you're just barely using the class system in C++ to store functions. Like they could just be modules, right? So let's see if we can get it to work, and then I'll undo it and we can rebuild it. Yes, it's not, you have to be really clear. You replace X in this function, right? Draw a background. So you'd say replace draw background. And I'm assuming replace it. Yeah. Yeah, it's just not accurate enough. Too many arguments for maybe that's a slightly different API. Oh. Oh yeah, underscore. Wait, what the fuck are you talking about? Not a string literal and no format arguments. What are you talking about? There's a fucking format argument right there. What the fuck are you talking about? Not a string literal and no format arguments? It is literally a string literal right here. Oh, is IamGUI text like a fake printf? Oh, I hate that shit. Because if they don't write it correctly, then you have all these issues. Alright, so that API is most likely wrong. Does this code even run? Too many arguments for format. Is it using the printf style? Seriously? Oh my god, man. So this code isn't even correct. Yeah, this code is buggy. Alright, well, it's most likely gonna crash. We'll see. Yeah, right? Yeah, and where are these getting set up? No, I think we're at a point where this code is just not right. Yeah, it's just getting to a point where like it needs to be restructured, significantly restructured. Let's see what this segfault is. Init background pipelines 524. Yeah, this isn't good. All right, we're gonna undo all this. Okay, so the code in this module is just straight up busted. It doesn't compile. It's got significant bugs. It's unclear where you put this code. Like, is it in addition to the other code? So you're having to sort this out yourself. And I feel like this started with the last chapter, the last part of chapter 2. Everything was going good, no problems. And then I think it got down to the end where he's just like, yeah, throw it into the thing, this part. Where he's like, go back to draw background and just throw it in there with not clear instructions that this replaces the contents of it. And I think that's where it started to go downhill. Because then you get the I am GUI, and this is kind of like, this works, this is fine, but again, it's a lot of like, no, this one's fine, and then again, just getting lazy, right? You don't know where you put this code, you don't know where you put this code, it has bugs, the code down here just doesn't actually run, because he's missing the %s. So I feel like at that point, it's broken. Now, you could take this as an exercise to try to learn this, but yeah, no, I think we have to stop there. Because it just doesn't work. Yeah, if the code is busted and the code is shit, then your writing is going to be shit. That's just the way it works. If your code doesn't read well, your code isn't organized well, it's going to be difficult to write about it. And this is just piling and piling and piling. You just adding more lines and more lines and more lines instead of restructuring it, kind of figuring out how to do it, right? Yeah, so VK pipeline info. Yeah, see, it's really unclear whether you put this code here or you placed the whole function. Let's just try it one more time, and also it's not clear where you, okay, so from here down to here. Let's try this. Yeah, see, this should be its own separate function. Instead of just like dogpiling just tons of code into this one thing, there should be like a separate functions. You go, okay, now make this function, now put it here. Make this function, now put it here. Okay, so let's just confirm. We'll leave it there so I can see where I did it. Yeah. Okay, so here, it should be after the compute draw shader. Where do we see that? Yeah, here. Okay, let's do this. I missed the Vulkan learning streams. How do you like it so far? I definitely think Vulkan is way better designed, but the complexity is off the charts. And I feel like that's a failure of the design. I feel like it's way more logical. It's way more like, you know exactly what's going on. Whereas with OpenGL, I don't know, like, oh, hey, I did this buffer and I did that buffer and now they're connected. I don't know why. And with Vulkan, you go connect this buffer to that buffer. But in Vulkan, you go connect this buffer to that buffer. And here's 700 lines of information about how to do that. So it's very different. But also the main thing I see with Vulkan is that it's a transactional API. So you go begin commands. Here's all the commands, end commands. And that's probably why it makes it so much better for like performance and threading and whatnot. because you're very clearly separating, one, all the data is there, so you can put in threads properly. You can fence it. Everything. Push Toys got the right. Yeah, Push Toys got it right. Vulkan is insanely verbose, but OpenGL is horribly cryptic with no feedback. Exactly. That's the best way to put it. So I can fix verbose, right? Verbose, I can refactor and kind of clean up verbose, right? I can't fix cryptic, right? There's no way I'm going to go and make OpenGL not be weird, right? It just, that's the way it works. But with Vulkan, I could conceivably sit there and kind of like figure out like how these things go together and come up with an alternative, layer over it that fixes it. And I think that's the reason why people are using it now, right? Because you can take anything that's very complex and create a better API on it, right? Yeah, dude, this code is fucking busted. There's just no way. There's no way he's doing this. There's just no way. A whole bunch of shit is not initialized. I don't understand how do you have this code and it just does not run? It's like the biggest sin of programming documentation. Yeah, it's that same line. All right, so we would have to debug this, and yeah, it's fucking annoying. Yeah, see, where's the gradient pipelines get initialized? Yeah, quit, god damn it. So I do this. So they're being used in the render loop. So he makes one shader. Compute effect. No, yeah, it just falls apart at this point. I am kind of curious to see if I can fix it, but it's missing a step. Also, why the fuck does this thing constantly download debug info? Like, I never want to hear another Linux user complain about Windows, man, because like the fact that this is constantly downloading info from ubuntu.com and every Linux distro is doing this means they're tracking you, man. They are totally tracking you. Oh, you gotta be fucking kidding me. Are you serious? If I say no, I can't do a backtrace into my own code? Okay, no, that just has to be running. I was about to smash someone straight in the face. That's really bad. Okay, 520. Let me see. This is missing. Yeah, this is just not working. Okay, let's do this real quick. Compute gradient pipeline layout, gradients there. Let me just make sure I'm in init background pipelines, yeah. Compute pipeline create info. There it is. Gradient pipeline layout. Yeah, we create that. And compute pipeline layout. Sky shaders. All right, so data gradient. I'm kind of not sure which one of these would be causing it. Where did we create the gradient pipeline? Where did we create this? This exists. Where did we create this one? Yeah, where's gradient pipeline? There's no gradient pipeline. No, but that's supposed to create the gradient pipeline. So something in pipeline create info is missing. Pipeline layout. Compute layout. Yeah, okay, so we create the gradient pipeline layout there. And then we have compute shader. Let me just look at this. Is this created anywhere else? Yeah, this is a mess, man. It's really unclear where you're supposed to put this code. And also, I think it just has a bug. Basically, there's something wrong in here. So in the compute pipeline create info. VK structure pipeline create info. Stage info. Gradient shader. Oh, okay. All right. This is wrong. This is wrong. He has his shaders in a different spot. Wait, so why didn't I get an error? Hold up. Where's the error? Error. Okay, I'm going to change this. Change this real quick. Okay, that's the bug. And we don't want to say. Actually, let's leave that in. Let's make these hard error. Do I have a board? Hold on, we'll find out in a second. Okay, so this one will pass. Let's just throw that in real quick. Is it also uploading? Yeah, because it has to upload the name of the libraries they're using. So basically, they're tracking everyone's coding. What libraries they use, when they use them, probably the program they use it on, like all kinds of info is being passed to that. Line numbers where the things happen, and downloading it every time is just real stupid. Like a network access every time I use the debugger, that's fucking nuts. So anytime you see that where it's constant network access, it's tracking. Also expensive. I don't know anyone who would want that. Okay, so now too many arguments to function abort. Okay, whatever. Fine. Aborted. Fantastic. All right. Now we're going to get a better error. Let's do this. So we see it. Okay. It's still very vague. This code is very vague. It's really unclear where it goes. I'd block that in my firewall. Yeah. Okay. New seg vault. confirm it compiles. Good. We might need the next part of the thing, but let me just double check it's not something in there. I guess I want the debug info for everything again. Wow, why haven't people revolted, man? Okay, yeah, so I think now we're at a point we have to have the next piece of code. Let me just confirm. Draw background 398. Yeah, okay, cool. So this needs to be replaced. I think I have that. Yeah, you keep saying the render loop. You have to be exact. You have to tell people exactly what to change, man. Alright, so I'm assuming it's this. Alright. Okay. Still showing the demo though. Okay. So, demo, get rid of that. Okay, so this is the next part. So I'm just going to get this to work and then we'll go back and redo it manually so I can learn it. Okay, so from new frame to here. Okay, and it also doesn't work. That's the other thing. So you have to sort out. I'm telling you, man, it's because he has 4 elements to that struct, but he's only using 2. Okay, yeah. This is extremely buggy, extremely buggy. No, I'm guessing this is getting set to zeros. All right. Well, I guess we just have to figure out why it's busted, but yeah. I think it kind of gets you going, but it gets real sloppy at this point. Okay, so let's undo it. We have an ad starting, but easier to start from scratch. Oh, I doubt it. No. Like, it's good that this resource exists. Like, but I know free is not an excuse, man. Free is not an excuse. You still want to produce high quality, right? All right, so we're gonna do that. That's the point where we have to solve this bug. So we had an ad starting. So see how it's going to blink green in the background? Yeah, this, we got to fix that. And it's just getting to a point where it's so complicated. It's not the length of the code, it's the fact that things are not chunked up into concepts, right? So for example, in this draw function, draw could be like 5 or 6 functions that explain each thing that you do. Okay, so let's turn on validation layers and then I'm gonna go make a bagel and cream cheese. and get something to eat. This will require brain power. Okay, yeah, so we'll have the validation layers tell us what is possibly wrong. Yeah, I think we're missing something on the push constants. Okay, we'll just use this to debug it. DQ burger at. Alright, I'll be right back, folks. Getting some food. Twitch recap. I'm your second. Oh man, I gotta work harder. Maybe I need to do some hot tub streams. Oh, that'd be terrible. No way. No way. Oh. Just even thinking about that makes me cringe. Is hot tubs even like a big thing on Twitch anymore? They kind of killed that with fire at some point. Pipeline doesn't have... Okay, yeah, so this pipeline seems to be misconfigured. Okay. Right, I got my bagel cooking, so I'm going to eat that. Hot tub streams with grandma. Yeah, right. It's almost as cringe as my voice acting. Okay, so there's an issue. I'm kind of curious to try to solve all of these validation errors. Also, I kind of really like this validation system. It's impossible for them to do, but if it could be linked to your code line numbers, oh, that'd be fantastic. Yeah, it looks like the push constants aren't created right. So we'll go look at that. What font is that? Let me see. It's just some default font that comes with Linux. Liberation Mono? Oh, I'm on Linux. Anyways, that's the name. Liberation Mono. Okay. So the report is that it looks like this pipeline pipeline layout doesn't have a push constant range. Let me see. VK staters. Okay, so let's look for this. Yeah, here. So the gradient layout pipeline isn't configured correctly, it looks like. Push constants are used, but VK pipeline layout doesn't set VK shader compute bit. Okay. So this, yeah, so this most likely goes all the way back to this, where it wasn't clear where you put this code. I got no idea where this goes. Set the push constant so we need to change the code that creates a pipeline layout at the start of init pipelines. There's nothing at the start of init pipelines, man. You have a background function. There's no clear. I mean, come on, people. It's all you got to do is just like go through your own stuff. Don't just dump shit out of your head. Go through it and like try to recreate it. I go through my exercises like probably like 10 or 15 times. Like I write them and then I start and I go back to start, go back to start, go back to start. Do it fresh over and over until it's smooth, man. Alright, so it's unclear where this goes. Alright, so I'm going to assume that this is actually not here. So it most likely replaces this. I'm guessing it replaces this. I don't know if it's in addition to this. But then where does the compute... Alright, so here's the compute layout. Okay, so it looks like it replaces this part. And that will give us the center stage compute bit. Yeah, this needs to be broken up into multiple functions. So this is pointless. There's no reason to have this init background pipelines function. What should happen is you have a function that covers this part. Give it a real name like initialize pipelines. Then this part, initialize shaders. Then this part. And you create 3 functions. And then you tell people replace. And then a pipeline cleanup. And then you tell people replace this function with this code. That's it. You just replace the whole function with it. Instead of having them try to figure out where to put it. Okay, so if that's now there, yeah, because effectively what we did is we overwrote the previous pipeline config with a new one, or added an incorrect one. So now we should get rid of that first. Okay, yes. So now we have a correct gradient. Okay, we have I am GUI and it should go red to blue. That's actually in there. Okay, good. Okay, so now we need to hook in the I am GUI stuff. And again, it gets a little weird. Okay, so now we're at the next part of it. I really think a tool, see, I have the exact same problem, right? Like I can give you a really good example from my own course, right? So I have these lessons in Go, right? That have you make a game in Rogue, a game called Rogue, just a little terminal game, okay? Right? And it's the same deal. You build it up over time. Like as you go through it, you type up the code and you build it up, okay? So I have the same issue because I have to tell them in the next exercise, now you have to change this thing to look like this, right? So I have a repository. Here. And in this, I have to do like 01, and this is the code, and then 02, and I had to do like a diff on each one so I could show you what to change, right? But you know, diffs are tough to read for people, you know, it's not like easy, but it's better just because it's exact, right? A diff is going to nail it every time, right? But this is a difficult thing in both books and videos. It's hard to tell people. And even if you think about it, like, how would you go and look at a Git repo and see the code changing, right? It's kind of hard to like visualize or see like how code evolved over time. And that's effectively what I need. What I need is a way to say, here's stages of a project, and then a tool that let people browse it in stages to see what changed. So that way they can know how to change it, right? So I have to do these diffs. So when you come here, I have diffs again. That was the only solution I came up with. So, for example, I got this. Now we add the screen. And then I had to do this too, where I say like, okay, we're going to put, this is going to be the next line. So they comment out the lines and then we build them up in sections. 0, 1, 2. And then if you look, this code is just basically the components, right? So I have make the new map, then initialize the screen, then render, and then later on we change it to this render, but this is like the best you can do. Like I honestly can't think of a better way to do it. In the VK guide, he needs to be way more clear about how you change this and where you change it, right? But using line numbers doesn't work, because then you'd have to have them copy your code exactly, line for line, right? So like you can't do it this way. So you need a tool that basically would take the code apart. As you do changes, so see, now I'm at the map. Now you make the map. And I break it up where like you have the whole thing. But then, still this sort of same problem. Right? You get to here. So then the next lesson, I have to explain how to use a diff. Because it's kind of the only accurate way to show how to add to the code. But it's kind of junk. Like, I'm teaching total beginners. I'm like, okay, we've got to learn how to read a diff. Because it's the only way you're going to learn to be able to say, put this code exactly here, right? And also, it's not going to be accurate because their line numbers might be off by a little bit, right? They can't just apply this diff. But it needs to be way more exact, This has to say, a diff. A diff is probably the best way to do it, right? But even then, and then also the code needs to be restructured to be way more, again, if the code isn't structured well, then the prose isn't going to be structured well. So like first thing I would do, I would go into draw background. I cut this up in, no, not draw background. Init descriptors and draw. I would cut init pipelines. I just get rid of this function, and then I would have init pipelines here be a sequence of functions. Push constants would be a function. Shaders initialization would be a function. Stages, pipeline stages would be a function, and then it'd be easier because then you would say, okay, we're going to add a function to here. Init shader pipelines, right? And then create the shader pipelines function. That makes it a lot clearer about where stuff goes, right? So chunk this up even further into functions. Then, utilize more of C++. I mean, right now we just have just Vulkan engine. I think this could be probably like 1 or 2. You could have like a pipeline builder. Couple of classes would probably simplify this a lot. We're going to change our pipeline builder to do this now, and then GUI. Yeah, separate the GUI out. We're going to create a GUI class, and you basically run the GUI class, run this class. Yeah, just a little bit more C++. Chunk these functions up so that they're sorted by, they're like organized by conceptual pieces. So we have this, and then we have this, and then we have this, right? And then the function name helps me remember what it did. Yeah, anyways. All right, so we have that working. And my audio keeps popping. Okay, so we still have some errors with the memory barriers. I think that's been there for a while. All right, let's get the GUI up and running, man. That's good. And that's good. Okay, great. Actually, I want to play with this real quick. PC data 1. Okay, so this is red to blue. So let's change this to, let's do like 1. Let me do this, 0.5. And let's do 0.5. Just to confirm I know that's it, what's doing it. Go with Vulkan for things like init background is much clearer as one single function. Yeah, no, I just disagree. It's not clear. And it's not necessarily whether it's clear for someone who is a graphics programmer. It depends on if it's clear for the pros. So for example, if you have this, right? This here, when you have, or let's say this part, right? Pipeline, compute pipeline, create that. Instead of saying just put it at the top of init pipelines, which doesn't work because init pipelines is just a single function call. So that instruction is unclear. Right? Just calls init background pipelines. So what I did is I put the code here, exactly what it says. We need to change the code that creates the pipeline layout at the start of init pipelines. It's actually at the start of init background pipelines, and you replace these lines. If init pipelines was a sequence of functions, this is one concept right here. That right there is one concept, initialize the pipelines. This is one other concept, set up the shaders. This is another concept, initialize cleanup, pipeline cleanup. So all three of those could be done as separate functions. Now, when you want people to change the init pipelines part, this part, you just say replace the contents of the function with this. It makes it easier to write about. Instead of, well, this is unclear. Put it at the top of init pipelines. Okay, I did. It doesn't work. Let's actually replace this part in the top of init background pipelines. Okay, so now that changed the color. Cool. All right, that's good. Okay, so now the next part. Okay, we loaded the shader. We initialized that pipeline. Now we need the compute effect. I think I already have that. Hold up. akengine.h. Yeah, compute effect. That's working. And we also have the data we have to set up, right? Where's this? Current background effect. Yeah. Also, I'm not sure why this one variable doesn't have an underscore. I'll have to change that. Let's get it to work. Okay, so now we learned that we have to find this. So after this part, from here to the end, gets replaced. Let me just confirm that's correct. And then we'll type it up to learn it. Okay. Oh yeah, and let's get rid of format. I should go back to format though, based on the problems with statically compiling it. It does become a problem. Goes in init background pipelines. Yeah, and it's in a lot of places where that's being done, where it's unclear where you put stuff. But at the same time, it's very difficult to kind of tell people how to fix that, right? Or like tell people how to make changes in a course book. Like I struggle with it too. And so that's why I say like you have to organize the code so that it's very easy to explain in pieces, right? And this code could be way better structured. A lot more chunks, using functions to define the conceptual pieces. And then it's just a matter of telling people to change the concept. Change this one thing here, there, that one thing there. Okay, so we should get a seg fault, but let's just confirm. Right. Backtrace and network background pipelines 509. Okay, yeah, so this is the same issue, and I now totally forget how it's fixed. VK Stager module handle. Invalid. Oh, yeah. This was the same error. Okay, yeah. I have my stuff in a different place. Okay, cool. Yeah, this should be like a more harsh error there. Oh, no, it's still not right. Okay, we'll confirm that works. And then we'll redo it. That debug info D is just so annoying. Okay, draw background I think won't work until we get the actual stuff, but let's just confirm. So the rest of it goes. Yeah, okay. Because draw background needs to be rewritten. Okay, so that's good so far. Okay, let's undo all that and redo it. Okay, cool. So right here is where we put this block of code. You know, I'm going to change this up. Hold up. Okay, and let's confirm that actually bombs out. Yeah, okay, cool. Abort's working. Make run. Failed to load gradient color. Perfect. Kind of a quick and dirty design by contract thing. Okay, then we load the sky shader. I wonder if I should change the load shader module to just do that, but nah. Oh, let's fix this real quick. Okay, so now we need sky shader. And same thing, device and sky shader. I'm just gonna copy paste that so I don't fuck it up. So every time I make these, there's this next pointer. It's always set to null. What is it? Is it something where I could chain these together and in a single function call initialize them all? Like you create a whole bunch of stages, next, and then you go, and it just follows the linked list effectively. Because if it's not that, then why do they have it? They should just remove it. To be like, nobody's using this, so yeah. You don't need to set it, just always set it to null. Well, let's compile that just to check it real quick. Just for extension support? Interesting. Yeah, that's fine. Wow, getting all the spam calls today. That's the structure type. Alright, check it real quick. I compile this. VK create a compute pip lines. Background effects. Okay. All right, now this is not gonna run. Let's just confirm. Is that the draw? Yeah, draw background. That's fine. Okay, now let's skip this, jump to here, and redo the draw. There. This gets replaced. Compute effect. It's probably, yeah. Probably another super long one. Okay. Okay, VK shader stage compute. Yeah. VK. Compute push constants. Address of effect dot net address of reference. Data. No, that's address of. Yeah. and then VK command, dispatch command. And then this is the 16 by 16 cell. Yeah. 16.0 1. Okay. So that should fix the draw function. Then we can go back and add the IMGUI modifier. Assuming I learned how to spell. Jesus, how you doing, man? Vulkan time again, yes. I'm trying to think how far we can get with Vulkan. It's very educational, like I gotta say. Alright, okay, we're back. We're back in business. Back in business. Now we gotta change this so we can mess with it. Also, not too sure about these mistakes. We'll have to go and try unassign threading info. It may indicate a bug. Unassigned threading info, unassigned threading info. Okay, yeah. We'll finish it and then we'll see if we can track down what those are. Okay, so now, let me see. Now we get rid of this. Just for my own sanity. Yeah, see, if you do this, if you make this function, then here your instructions are replace the contents of render IMGUI with this instead of like find this code and do stuff with it. And actually these should be backwards. This is rendering it. This is drawing it. Yeah, anyways, we'll just do it that way. Alright, let's confirm from here to here. Alright, this is what we gotta do. Okay, I don't need to learn IMGUI. Let's paste it, study it real quick, and then we're good. Again, background, compute effect. Yeah, and this is wrong. This needs to have a %s. Okay, so then we have a slider for the effect index. So that will switch between sky and the other one. Then we have 4 data elements that are being taken from this. And it's input float 4. Got it. Okay, let me see. Okay. All right. Hey, look at that. That's way better. Yeah, too bad these aren't sliders. Maybe we can mess with this UI some. Also, we gotta figure out if these are what should be here. If the validation layers are like legit complaints. I'd almost think you'd want to make this have no errors, so. I'd be curious to run it and see if you get them. Then can we shrink it? Nice. Okay, so now, do you only change that? Can what if I change this? Yeah, that doesn't change anything. Oh, I see. So let's do 0.9 red, or G if I adjust to G. Okay, so it should be a warmer, maybe 4, 6, yeah. Yeah, there you go. What if we change this to 0.5? That's the number of stars. These inputs suck. Okay, lower values is more stars. Higher values is less stars. Above 1, so if we want like very few stars, we gotta do like 9, 9. Oh, 9, 8. Yeah, cool. Right, so then we can change the gradient color from, let's say we're gonna go 0.5 here. Yeah, so it's gonna give me an orange to a blue. Now if we set the others, that'll make it a dull blue. Yeah. And then we can do this. Yeah, there we go. Nice, and it remembers between the two. All right. Slider float, you think? Okay, we'll try that. Oh my god! Slider float. Float 4, I believe. For arguments to function slider float. Oh, that's right. You need a minimum. Oh my god, that's too much work. Wait, why is it a totally different API? And slider flags. Slider int. Moving on. I hate I am GUI, man. It's just like this totally random. This function takes this, but this function takes that. Classic C programmer shit. Okay. I'd rather see anything else. I think that's that whole tutorial. Or that part of the tutorial. All right, so now in graphics. We're now on chapter 3. Oh. Okay, so I gotta think about, let's take a look at what we're doing, because I really want to refactor this code to help me understand it. Building a graphics pipeline is a far more involved task than building a compute pipeline. Awesome. And pipeline layout. Tons of options. We'll be creating a pipeline builder structure that keeps track of all those options. Now, I'm kind of curious, why doesn't, what's that thing? VK Bootstrap, it doesn't provide help for this? I feel like VK Bootstrap is kind of like lacking. Yeah, you would think it would have that. Vulnerability, let's take a look at what we need to fill, right? Okay. Stages, stage count, so there's a whole bunch of options, okay. And then we're gonna make a builder. All right. And then you have each thing that you need to add to it. Okay. Build pipeline, there we go. Clear. Okay, that resets. Build pipeline. Viewport, scissor. Okay. All right. I can't do the Christmas music and also Vulkan at the same time. That's too much sand in my mouth. Make a bootstrap for startup. Yeah, but can it do all of this? Like, it just for educational purposes, we're making one, but it can do more. Because it seems like it's like, yeah, VK Bootstrap could have done a lot more. My headphones are messed up. Give me a sec. Okay, so we create that. Yeah, I don't think any of that's too hard. It's just, again, like filling in structs. I think a lot of complexity of Vulkan is just the amount of info you have to put into structs. Because the actual structures, you know, like if you go look at this code, right? And that might be like a way I can sort of get my hand around it. So let's say draw. Here you're waiting for the fence, right? Okay, and you flush it and reset them. So this here, a couple of functions and we're getting going, right? We wait for the fence to happen, reset it, ready to go. Okay, and then this, we get it an image from a swap chain. We get it, no problem. And now all of a sudden, anywhere from like 5 to 8 lines of code, basically filling in a struct and handing it as a config. And that's like a lot of Vulkan. The actual structure is not that hard. I create a fence, okay, cool. I start a transaction, okay, cool. And then a lot of it is just like the connections are sort of hidden. Like the way you connect a thing to a device, you connect a pipeline to a layout, things like that, is just hidden behind just mountains of struct configs. Because in between, and then this is also being hidden even more, because like in here is even more stuff, right? So it's like between this and this, like if we go into the VK init, that. It's just filling in a struct. That's all it's doing. Right? So if you had that in there even more, like if we go back. So if we get rid of this, right? Just sort of like illustrate the issue. So I reset the command buffer, and before I can begin the command buffer, it's just configuring a bunch of structs. That's it. So that's where I feel the complexity is at. I don't know how you would solve that because, well, I think the first thing is that in C, this is easier. But if every time you go to call a function in Vulkan, you're filling out, you're using like 10 or 15 lines or 8 lines just to configure some internal data, that's going to make it way more complex. And also difficult to see what's going on, right? Because the command buffer is hidden behind a lot of configuration. So that's the advantage of OpenGL, right? Is that all of this, basically this like configuring the buffer shit and filling out these things is all behind the scenes. But OpenGL's flaw is too much is behind the scenes. So it's order dependent, which makes it not thread safe. So you have to like create a VBO and then just call functions on a VAO and it's connected. Like, no, like you want to be able to explicitly say, connect this to that. So it's almost as if when they made Vulkan, they saw how thread hostile OpenGL was, right? And they go, we got to fix it by making everything explicit. And then they went absolutely batshit crazy and made everything explicit, assuming nothing. I feel like there's a happy medium of like, you know, things are kind of have reasonable defaults and it's more about connecting pieces together. You say, I want this pipeline to have there and include that stuff. And it's configured elsewhere, right? But it's not behind the scenes like in OpenGL. I gotta make sure I didn't totally fuck this up. Okay, cool. That's done. Okay, so then you create this. You give it the shaders. Got it. Set the input. Got it. Set the polygon. Set cull. Yeah, okay. So you just make a pipeline builder like that. Disable depth test. Okay. Yeah, this is a lot. Woo. Yeah, so then you have the two shaders you need. Okay, to make a triangle. In the Vulkan class init triangle pipeline. Okay. You load the frag shaders. Yeah, I could see simplifying that. Okay. Create pipeline layout info. Yeah. So then you just do set the shaders, set the input, set the polygon, blah, blah, blah. Okay, cool. And then attach it. And then you have draw geometry. Yeah, okay. Okay, I got to research transitioning an image. I don't understand what that's actually doing. Then you have your viewport and your scissor. Another thing I need to remember what the fuck a scissor is. I read about it one time and then I'm like, that's weird. Just use a viewport. Okay, and it draws a triangle. Okay, so I think we're gonna call it there for today's Vulkan experience. I wonder if I should include the SPV file. Yeah, why not? Okay. Okay, so I have to think about how I want to spend the next session. I really would like to take a stab at sort of cleaning this up some, But that's always a big risk because until you've kind of completed all of the tutorial, you don't really know where it's going. Like I could refactor it out and then end up having to just reverse engineer my own code to get this to work. So maybe I'll research. I'll see if there's like, it's possible to kind of start the refactor. Cause yeah, I'm positive I could chunk this up a bit better. I'm thinking like 2 or 3 classes would probably simplify a lot. Maybe some mechanism for getting some defaults on some of these things. Cause like so much of this, man, is just like, yeah, that's an integer, that's an integer. Like you could probably set everything except for like the pointers on these things. Not sure how to do it, but I think a first step is to kind of take this code and peel out concepts. Yeah, you're like here, take this out, okay, and then take this out. Like literally, there's a concept. If you got a comment, then that's a concept, and pull it out, and pull that out. So that'll be interesting. I think I'll try that. Maybe I'll do a branch. We'll see. And then that'll test my understanding what so far I need to do. And then I need to, the only thing in the back of, well, not the only thing, but the main thing in the back of my head that I'm like, what the fuck is going on is the transition image. Like, why the fuck are we calling this all the time? So I don't understand what that is. I'll have to go read up on that some more. All right, y'all. Rotato. Everywhere you're at, it's a snow day. Veld, how you doing, man? Happy Tuesday to you too. They come in right as you were ending the stream. Yeah, there's no problem. Yeah, I've been going for about 3 hours, and I do have other work I have to do. Did I push this? There's only so much Vulkan you can handle in one day. Okay. It's honestly not so bad so far, right? But we're just doing kind of basic compute stuff, right? It's just the config is really the thing that gets you. Like it really is just that there's so much config info you have to put together. So many structs that you have to like configure in specific ways. But the actual connections between things, I mostly understand it. Like you create pipelines, you hand it to the thing, you tell it how big the pipeline is, then you add things to the pipeline, and then you load your shaders and add the module, you know. All right, let's test it on Linux, on Windows. Well, I'm almost done. We gotta do the Windows test. I don't think I need to do a reset. Right, we're good. I'm curious about that startup. Neat. Well, there we go. It's real nice that it's cross-platform like that. Yeah. Other than just like on Windows, debugging is a pain in the ass, but in Linux it's very easy. Yeah, not having access to the easy access to the validation layers is just a crime. Like it's just a fucking crime, man. I don't know why they did that. Yeah, having to run it with a special GUI is just wrong. I don't know why. It's a Windows thing. I don't know why people like running shit with GUIs or configuring CMake with GUIs. It's like, if you gotta do that, you failed. Programming is no GUI. All right. Let me get everybody a link to this code.
if you would like to check it out yourself. And then I think what I'll do next Vulkan session, I'll do a branch and then I'll try a refactor. See if I can kind of chunk this up, clean it a bit, but without deviating too much from the design. So I'll experiment with either just creating a bunch of functions and then possibly maybe I can totally see Vulkan engine being separated from the GUI. I think that'd be the first thing I would do, is pull the IM GUI stuff out and then have it be a separate class. Okay, so if you have suggestions on this, you can email me at learncodethehardway.com and schedule. I do this again tonight at 10 p.m. All right, that info is in the chat. And let me find you somebody to raid.